Hello and welcome to lesson 3-4. Today we're going to look at using similar triangles. Before we can look at similar triangles, we have to first understand what it means for triangles to be similar. So in order to have similar triangles, our angles of similar triangles are going to be the same. So it says when two angles in one triangle are congruent or the same to two angles in another triangle, then the third angles are also congruent. Okay, and the triangles are similar. So if you remember, if two angles are the same, okay, so let's say the 95 and 65 on both of these, then that means that the third angle has to be 20 in both because a triangle will always add up to 180 degrees. Remember too, when we're talking about similar triangles, notice that when I name triangle ABC, I go A, B, C, or I'm doing the 65, 95, 20 degree angle. You have to name it in the exact same order on that second triangle. So triangle DEF would be 65, 95, 20 as well. Let's go ahead and take a look at example 1. So for example 1, part A, it says tell whether the triangles are similar, and then we're going to explain why they are or why they are not. Now when looking at part A, I notice right away that I have angles that match up. So I have a 75 degree angle here and a 75 degree angle there. And then I have a 50 degree angle here and a 50 degree angle here. So because I have two sets of angles that are the same, that tells me then that angle X is going to equal angle Y. Likewise, for part B, when I start looking, I do notice right away that I have a 90 degree angle in each of these, but now I'm going to have to see if they're similar. So what I'm going to do is I'm going to take and look at this first triangle here. So I know if I take X and I add it to my 90 and I add it to that 42 degree angle, that these should add up to 180 degrees. So when I simplify this and I collect my like terms, I get X plus 132 equals 180. And when I solve for X by subtracting 132 from both sides, I get X equals 48. So when I look over here at this other triangle, I see that I have my third angle as being 38, not 48. So that tells me that these two triangles are not congruent, which then means that they are not similar. Now, I'm going to ask you to try and do numbers 1 and 2 here by pausing the video and then come back and double check your answers. All right, so for number 1, again, I notice that both triangles have an angle of 28 degrees. They are different in the fact that we have 71 and 80, but that's okay. What I'm going to do is I'm going to take this top triangle right here and I'm going to add up all my angles. And I have 28 plus 80 plus X equals 180. So when I collect my like terms, I get 108 plus X equals 180. And if I subtract that 108 from 180, I get X equals 72. Well, notice in this other triangle here, I have an angle of 71. So because 71 is not the same as 72, that tells me that these are not similar triangles. Likewise, I'm going to go and do the same thing for example 2. So I'll start with this triangle here, and I can see that I have 90 plus 66 plus X equals 180. And I'm going to take and I'm going to add that 90 and 66, and I get 156 plus X equals 180. When I subtract 156 from 180, I get X is equal to 24 degrees. So if you notice in this other triangle, I've got the 90 degree angle here. I do have a 24 degree angle, and that's going to tell me then that my X and my Y then are going to be the same. So these two triangles are similar. So I'm just going to write yes on this one. Now for example 2. Example 2 says, can you determine whether triangle JKL and triangle JMN are similar? Well, if you notice, in this triangle here, it looks like I have a big triangle and it's being cut by line segment KL. And notice they give us the notation for parallel lines. Okay, so because these are parallel lines, I know that I have congruent corresponding angles. So that means that angle L should be the same as angle N. Likewise, angle K should be the same as M, and both triangles share angle J. Therefore, the two triangles JKL and triangle JMN are going to be similar. So again, it would be yes, they are similar. And if you wanted on a side note, you could even go back and say if I have two parallel lines that are being cut by a transversal, remember angle L and angle N, these are corresponding, just like angle K and angle M are also corresponding. So again, please pause the video and try to do this on your own. Now when I look at example 2, or sorry, number 3 here, it says, can you determine whether triangle PQR and triangle TSR are similar? Right away, I notice that both of them have a 90, so they do share that. And I do see that they both have parallel lines. However, they're not being cut by the same transversal. Okay, so I have TR here, and I don't know what this angle T is. Likewise, I have parallel line P, or I have a segment PQ and another transversal, but I don't know if these are cutting, if PR is being cut at the same angle that TR is. So I can't compare P and T directly, and then I'm also not given any information on angle R on either one of these triangles. Therefore, I can't conclude that there is enough information to say that these two triangles are similar. So I'm going to say no, they are not similar. Another neat thing that we can do with triangles is we can use something called an indirect measurement. Now, an indirect measurement is where we're going to use similar figures to find a missing measure when it's hard to find one directly. And I'll show you how that works here in example 3. So example 3 says, you plan to cross the river and want to know how far it is to the other side. You take measurements on your side of the river and make the drawing shown. We have to find the distance, x, across the river. So you can see here that we know that we're 60 foot here. We have 50 foot to this point here and another 40 foot to you. We don't know how far it is across the river, but we can use the information that we're given. Okay, and this is where you can use those similar triangles. Let me grab a color here. Okay, so what I can do is I can say that side length x is similar to 60. So if I set this up as x over 60 equals, now because I used my variable side or this part of my triangle first, I have to use the corresponding side out of that. So I'm going to use my 40, and then the corresponding side to the length AB, or the 60-foot side, would be this leg, BC, which is 50 feet. Now you guys can go ahead and use the butterfly method and solve this. And you're going to get 50x equals 2,400. And when you solve for x, you're going to end up with x equals 48 feet. So you know that that distance across the river is going to be 48 feet. Okay, and finally, please try this story problem on your own and then come back and double check your answer. So for our last example here, it says that you plan to cross a river and want to know how far it is to the other side. You take measurements that are shown in the diagram, okay? And we're going to look to find that same measurement, okay? So again, I'm going to start out with corresponding sides. And I personally like to start out with a variable. So I'm going to start out with x on the top, and then the corresponding side length to ED off the small triangle is going to be AB, which is 50 feet. So I have x over 50 equals, then I have 30 over 40. And now if I do that butterfly method, I end up with 40x equals 1,500. And when I divide these out, I end up with x equals 37.5 feet across that river. Please let me know if you have any questions, and I'll go over all of those tomorrow in class. Otherwise, I hope you guys have a great day, and we'll talk to you later.